Hello. Hello guys, good afternoon to all. I'm launching the technical poll. Please respond to the polls. Okay, so poll has not been created. Respond in the chat box whether my voice is clearly audible to all or not. And so also respond in the chat box whether my screen is visible clearly or not. Yes. Shall we start? I hope all things are good. Okay guys, so today we are going to start the second lecture of application of derivative, right? And we'll try to finish all the concepts in this class, and we'll revise all the concepts with some questions we'll solve. Okay, so let's start. Okay, so in this session what we are going to discuss, that is, first we will see monotonicity, then we'll see increasing and decreasing functions, then we'll discuss what is Rolle's theorem, then we'll discuss what is Lagrange's mean value theorem, and also in finally we'll see maxima and minima, local maxima, local minima, and global maxima, global minima, right? So let's start. So first of all, we should understand what is monotonicity. Monotonicity means either a function is increasing or decreasing. When a function is increasing or decreasing, either increasing or decreasing, then we can say that function is monotonicity in nature, monotonic in nature. That means, suppose we'll take some examples, like we'll take e raised to x. Suppose we'll take e raised to x. Actually, what is it? It is actually monotonically increasing function. It is increasing. Okay. Okay. So likewise, you can take another example. F of x is equal to minus x cube. So it will be a decreasing function. It is actually strictly decreasing. That's why we can say it is monotonically decreasing function. Either the function may be increasing or decreasing. Okay. Agar likewise, one more condition, one more case will be arising here. Suppose some functions are increasing and also decreasing in their domain. Like if we'll take example of sin x. Sin x is increasing sometime in 0 to 2 pi. 0 to pi. Okay. Sin x is increasing in 0 to pi by 2. And then after pi by 2, it is again decreasing. Similarly, ये उसका क्या है, ग्राफ है. तो sin x is increasing in 0 to pi by 2 and pi by 2 to pi, it is decreasing. So sin x जो domain है ना, domain of sin x is R, real number. So in real numbers, it is somewhere it is increasing, somewhere it is decreasing. That's why this function can be said it is non-monotonic function, right? It is a non-monotonic function. Okay, I hope this is clear to all. Let's move. Okay, so how can you understand what is monotonicity of a function at a point? So see here, you have in your screen, you have a picture, graph. And suppose it is my graph, y is equal to f of x. Okay. So take 2 points. Suppose I am taking a point at x is equal to a. X is equal to a, so the value of the function will be f of a. And take the neighborhood of point x is equal to a. Suppose that neighborhood I am taking a minus h to a plus h. So for h is very, very small, I am taking. Okay. So check. You can see here f of a plus h is greater than f of a. So this is my f of a plus h, and this is my f of a, and this is my f of a minus h. Right? Okay. So f of a plus h is greater than f of a, and f of a minus h is less than f of a for some positive h. Okay. Then if these two conditions are arising, then we can say that function is monotonic increasing. Similarly, you can take another figure also here. At x is equal to a, you have function value is f of a, and this is f of a minus s, this is f of a plus s. So you can see here f of a plus s is less than f of a, and f of a minus a is greater than f of a. If these two conditions are satisfying, then we can say that function is decreasing, monotonic decreasing function. Okay, so this is all about your understanding of monotonicity of a function. So, okay, so let's understand the concepts in more details. And suppose you have here 4 figures. See, this function is increasing at x is equal to a, and this function is decreasing at x is equal to a, because after p the function is decreasing. Okay, here also function is increasing at x is equal to a, and here the function is increasing at x is equal to a. And it's very easy. Let's move. Increasing and decreasing function. Okay, so simply we can understand here f is said to be increasing function in this interval ab, if x1 is less than x2. Suppose if x1 is less than x2 and we are getting f of x1 is less than f of x2, okay, then we can say this function is increasing, less than equal to ले लो. तो ठीक है. Next, if function said to be decreasing, less than equal to नहीं होगा, वही रखो same, है ना. Yes, ये अगर सेटिस्फाई करेगा तो मैं फंक्शन को बोलूंगा क्या, इंक्रीजिंग, है ना. सिमिलरली अगर ये जो कंडीशन है, इफ x1 is less than x2 and you are getting f of x1 is greater than equal to f of x2, then you can say this function is decreasing, है ना. Simply you can take any example. Suppose I am taking here a increasing function. Suppose this point is my x1 and this point is x2, है ना. So here you can see x1 is less than x2, and what you are getting, f of x1 is less than equal to f of x2, then we can say this function is increasing, right. Similarly also in other way we can say if f of x1 is less than x2, then if you are getting f of x1 is greater than equal to f of x2, then the function can be say decreasing. Okay, okay, so how can we understand the monotonicity of a function by using the derivative, you know this thing. It is increasing, function is increasing when if for the first derivative that function is greater than equal to 0, and when it will be decreasing now when the first derivative of that function is less than equal to 0, right. Remember, when f dash of x is greater than equal to 0, then we can say f of x is increasing, and when f dash of x is less than equal to 0, then we can say function is decreasing. So when we can say this the function is strictly increasing or strictly decreasing, ना just हटा दो इसको, इक्वालिटी साइन को हटा दो, f dash of x, if f dash of x is greater than 0, then we can say f of x is strictly increasing, only it is increasing, ठीक है. And f dash of x is less than 0, then we can say the function is strictly decreasing. Okay, so how can we define, if suppose a function that is continuous in closed interval ab and differentiable in open interval ab, okay, then how can we say the function is increasing or decreasing in the interval? Now, it is increasing, function is increasing if the first derivative of that function is greater than 0 in open interval ab, right. ठीक है. And f of x is strictly increasing function in open interval ab if that first derivative of that function is greater than 0 in open interval of ab. Clear? Okay, chalo, ठीक है. So these are all about, by using the first derivative we can check also whether the function is increasing or strictly increasing, decreasing or strictly decreasing, right. Chalo. Next, increasing and decreasing function. Already we have seen this. Okay, let's move. Okay, some results are here. You can take a screenshot of this screen. Okay, so when some results on monotonic functions, you can take a screenshot of this. Okay, chalo. Now we'll see. Okay, we have one example here, and find the interval for which function is monotonic increasing. So you have to find the interval where the function is monotonic increasing. राइट। तो कैसे कर सकते हैं हम उसको, बोलो। वी नो कि when a function is monotonic increasing, now f dash of x, if f of x is given as this, f dash of x is greater than 0, then we can say this function is increasing, strictly increasing, and f dash of x is less than 0, then we can say this function is decreasing. है ना? So we need to first find, okay, here, just a minute, yeah, here you can see this function, the given function है f of x is equal to 2x square minus log of mod x, है ना? So this function, what is the domain of this function? Domain हो जाएगा r, no, r तो होगा लेकिन 0 नहीं होगा, x is not equal to 0, because at x is equal to 0 log x will not be defined and all real numbers will be happen, है ना? Because in place of x if we'll take any negative real number also, then log x will be defined also. Okay, just let me check. Yes, ठीक है ना? So x is not equal to 0. So first of all, what should you do? We need to find the first derivative of that function. Okay, so first derivative क्या हो जाएगा ना? f dash of x will be 4x minus 1 by x, right? And if we'll equate this function with 0, है ना? We can write this also as, हम और कैसे लिख सकते हैं उसको? That is, if we'll take the LCM, this will be 4x square minus 1, है ना? We can write this as also 2x minus 1 into 2x plus 1 divided by x, right? ठीक है ना? Okay, so you should check whether the function, where the function is increasing and where the function is decreasing, right? So first of all, x not equal to 0, and for all real number we need to check, right? Just a minute, guys. We need to find the interval, na? Yeah, है ना? So just draw the Weber method, है ना? If I'll draw the number line here and take all the critical points. Suppose this is my point 1 minus 1 by 2, and this is the point 1 by 2, right? Okay. Suppose I am taking first x for x is greater than 0, है ना? For x is greater than 0. So x is greater than 0 के लिए if we will draw the, अच्छा, we are taking for numerator also, है ना? When the we need ना, that must be positive. अरे for this function to be monotonic increasing, that means ये condition होना चाहिए. That means this must be greater than 0, है ना? If we are taking x greater than 0, right, and we know for x greater than 0, that means denominator becomes positive. Understood or not? Denominator becomes positive, and whatever the numerator for x greater than 0, we'll check now, है ना? Okay, draw the Weber method. If you draw the Weber method here, Weber, so this portion is your negative region and this portion is your positive region. ठीक है? All right? Okay. If you draw the line at x is equal to 0 here, suppose I am drawing a line at x is equal to 0, right? And we know na, we are taking here for x greater than 0. For x greater than 0 and the region where the function, the numerator is positive. If denominator is positive, numerator must be positive. This function to be in monotonic increasing. So where the function is positive, we are getting for, and x is greater than 0, that is 1 by 2 to infinity. ठीक है? 1 by 2 to infinity. Okay. So when x greater than 0, I am getting 1 by 2 to infinity. Function is increasing. Similarly, if you will check for x is less than 0, where the function is positive, that is minus infinity to minus 1 by 2. Minus infinity to minus 1 by 2. So मेरा what is the answer? What is the final answer? क्या हो जाएगा बेटा? Now that is actually minus negative we are getting ना. Suppose here, okay. Okay, let's see here. Suppose we are taking na, x is less than 0. That means denominator is negative. So the function to be increasing, numerator must be negative. So we need the negative reason, right? We need the negative reason the function to be positive, है ना? So that means numerator denominator is already negative, we know, right? And numerator for numerator to be negative क्या होना चाहिए ना, -1 infinite 1/2 to 0, है ना? -1/2 to 0. ठीक है, तो मेरा फाइनल आंसर क्या हो जाएगा? फाइनल आंसर हो जाएगा, रिक्वायर्ड आंसर इज -1/2 to 0 union 1/2 to infinity. So this is the interval where the function is monotonic increasing. I hope this is clear to all of you guys. You are joining late, so late. That is the issue, है ना? ठीक है, चलो let's move. Okay. चलो. Okay. Next. It's already done. Okay. Now we'll see. Take these questions as your homework. इसको homework कर ले लो. You can take a screenshot of the screen. Take a screenshot of the screens and try these two questions in your room. है ना? Find the interval of the monotonicity of the following functions. Check whether the functions are increasing or decreasing, and where it is increasing, where it is decreasing. Like the previous example I solved here. Right? Chalo. Okay, now we'll discuss what is Rolle's theorem. है ना? So what is Rolle's theorem? Rolle's theorem says if a function f is defined in the interval closed interval ab, अगर एक function जो है that function is defined in closed interval ab and it is also continuous in closed interval ab and it is also derivable on closed interval ab and the value of the functions are equal at the end point of the interval, that is f of a is equal to f of b. Then there exists at least one real number c. Then there exists at least one real number c which belongs to the open interval ab. Then such that f dash of c is equal to c. Right? So, chalo, let's understand this theorem graphically. Geometrically, you can visualize better. Chalo. This is the geometrical explanation of Rolle's theorem. Suppose you have a curve y is equal to f of x. This is continuous in AB, closed interval AB, and differentiable on open interval AB. ठीक है? चलो, let's see. F of it is already given that it is continuous and differentiable in AB. Okay, and you can check in the figure also. F of a is equal to f of b. है ना? The value of the function are same at x is equal to a and x is equal to b. So what I am saying, there exists a point C in between a and b where the derivative, the first derivative of that function is 0 at that point, or we can say slope of that line, the tangent, slope of the tangent at that point is 0. That is f of a is equal to f of b. तो already मुझे दिया है ना? So here C is a point which is lying in between A and B where the slope of the tangent is 0, or we can say f dash of C is equal to 0. This is all about the Rolle's theorem. So let's see. Okay, chalo, this is algebraic expression interpretation of Rolle's theorem. That means between two roots A and B of f of x, है ना? There exists at least one zero of f of x. It's very simple. चलो लेट्स मूव. एग्जांपल एक वेरीफाई करते हैं रोल्स थ्योरम को. ठीक है, वेरीफाई द रोल्स थ्योरम फॉर द फंक्शन f of x is equal to x square minus 5x plus 6 on the closed interval 2 3, है ना? So how can you verify? First we should understand, we should know whether the function is continuous in the closed interval ab or not, 2 3 or not. अच्छा, फंक्शन मुझे क्या दिया है? That is f of x is equal to x square minus 5x plus 6, है ना? So it is actually continuous. It is actually continuous in closed interval 2 3 because it is a polynomial function. It is a polynomial function, and we know always polynomial functions are continuous. Okay, and also it is differentiable also. ये differentiable भी होगा. ठीक है? This is differentiable also in open interval 2 3 because because it is a polynomial function. Okay, if always remember polynomial functions are always continuous and differentiable also. ठीक है, तो ये हो गया first two conditions, it is satisfied. Okay, last condition, that is we need to find the value of the functions at the end points of the interval are same or not. So let's check f of 2, what you are getting. F of 2 is 2 square, that is 4, minus 5 into that is 10 plus 6. Yes, it is 0. Then check at x is equal to 3. F of 3 is 3 square, that is 9, minus 15 plus 6. Yes, it is also 0. So f of here, from here I am getting f of 2 is equal to f of 3, है ना. That means ये भी satisfy हो रहा है, ये भी satisfy हो रहा है, ये भी satisfy हो रहा है. That means very क्या हो रहा है मेरा Rolle's theorem, we can apply here the Rolle's theorem. Okay, we can apply the Rolle's theorem, right? So find C. Now we have to find the value of C. So how can we find value of C? We know when these three conditions are satisfied, we can say f dash of C is equal to 0. That means what is the first derivative of the given function, that is 2x minus 5 is equal to 3, right? So 2x is equal to 5. So x कितना हो गया, है ना? So x I am getting that is 5 by 2, है ना? That is 5 by 2. So what is the answer? Actual answer क्या हो जाएगा ना, c का वैल्यू जो है that is 5 by 2, है ना? So 5 by 2 is the point where the first derivative of the function is 0, right? The answer is 5 by 2. I hope this is clear to all of you guys. Let's respond in the chat box if it is clear to all. Clear? Shall I move? Chalo, ठीक है. Let's move to the next thing, that is Lagrange's mean value theorem. So what is this? Lagrange's mean value theorem says if a function f is defined in the closed interval AB and it is continuous in closed interval AB and is differentiable also in open interval AB, then there exists at least one real number C. Then there exists at least one real number C where C belongs to the open interval AB, for which or such that we can say f of B minus f of A upon B minus A is equal to f dash of C, right? Okay, let's understand this also by symmetrically also. Here you have the function y is equal to f of x. This is my function, है ना? And this is my point A and B. Already we know that the function is differentiable and continuous in AB. Okay, and मैं क्या बोल रहा हूँ ना, there exists at least one real C in between A and B. There exists at least one real C for which the first derivative of that function becomes क्या हो जाएगा? F dash C will be f of B minus f of A upon B minus A, right? This is the statement. Okay, let's try one other. ये तो हो गया सबका, है ना? And we know कि Rolle's theorem जो है ना, Rolle's theorem becomes a particular case of mean value theorem, है ना? It's a particular case of mean value theorem when f dash of C is equal to 0. You can see ना, if f dash of C is equal to f of B minus f of A divided by B minus A is equal to 0, that means मुझे क्या मिल रहा है ना, f of B is equal to f of A मिल रहा है. That means Rolle's theorem is a particular case of mean value theorem. ठीक है, Rolle's theorem is a particular case of mean value theorem, right? Let's solve one example. So see here, if f of x, okay, if f of x is differentiable in the closed interval AB, it is given that it is differentiable in closed interval AB, where f of 2 is given as f1 by 5 and f of 5 is equal to 1 by 2. Then there exists a real number C lies between 2 to 5. Then find the value of f dash of C, है ना? f dash of C हमें find out करना है. So that means मैं ये बोलना चाहता हूँ, ये differentiable है, that means ये continuous भी होगा, है ना? If it is differentiable in closed interval 2 5, है ना? So it is also continuous in 2 5, है ना? तो continuous भी हो गया, differentiable भी हो गया. Then we can say क्या? We can apply the Lagrange's mean value theorem, na? So we know f dash of C is equal to f of B minus f of a upon b minus a, right? So already we know na कि my f of b is actually that is f of 5 minus f of 2 upon 5 minus 2. So this is actually f of 5 is given as 1 by 2 minus f of 2 is given as 1 by 5 upon 5 minus 2 is 3. So this will be equal to, ये तो मेरा 10 हो गया, that is 5 minus 2 okay upon 3, that is 3 तो cancel हो जाएगा रे, 3 by 10 into 1 by 3, that is 1 by 10 or we can say 0.1 है ना. So 0.1 f dash c becomes 0.1, right? Clear everyone? This is clear to all. Let's respond in the chat box whether it is clear to all or not. Yes. Sure. Let's move. Okay, now we'll understand what is maxima and minima. So concept of local maxima and local minima. No need to go through all these theories. What I'm saying, take an example of your classroom. Suppose your school is the total area. School is a total big area, and in your school you have a classroom. This is your classroom. Okay, this is your classroom. So in your classroom, if I'll ask you to who is having the highest height, suppose you will say Ram is the boy who is the tallest one in your class. Okay, and Sita is the girl who is the smallest girl in our class. But in your school, Deepak is the tallest boy in your school. Okay, tallest boy in your school. That means here we can say, Deepak is your global maxima. Global maxima, and this Ram is the tallest one in your classroom, not in your school. That's why Ram is called local maxima. He is the tallest one in your locality, local maxima. And Sita in girls, Sita is the local minima. ठीक है. तो लोकल मिनिमा और भी हो सकते, लोकल मैक्सिमा और भी हो सकते हैं, है ना. तो ये हो गया मेरा कॉन्सेप्ट. दिस इज अ कॉन्सेप्ट टू अंडरस्टैंड व्हाट इज लोकल मैक्सिमा एंड व्हाट इज लोकल मिनिमा, राइट. ठीक है, ओके, ये तो सबको समझ में आ गया. सपोज आई एम ड्रॉइंग ए फिगर नाउ. ओके, so this is the figure and this point is x is equal to a and this point is x is equal to b, right? Okay, and suppose this is the point x is equal to c and this is the point x is equal to b. Okay, now try to join all the points. Okay, so we can say here who is the local maxima. Who can say who is the local maxima? Who can be the local maximum? Yes, at x is equal to c you are getting, ये suppose मेरा y is equal to f of x का ग्राफ है. At x is equal to c you are getting the value of the function is f of c, and at x is equal to b you are getting f of b. Sorry, suppose this is d, f of d, and f of a here you have f of b here you have, right? So we can say कि f of c is the local maximum. Why? Because in his locality f of c is maximum. You can understand here. In his locality f of c is maximum, but we can also say f of d is minimum, because in the locality of x is equal to d, f of d is the local minimum, है ना. So we can say local minimum is f of d, local maximum is f of c. ठीक है, but you can also say कि sir we can consider f of b and f of a also, f of a and f of b also. Yes, you can say but at x is equal to a, function is not differentiable. At x is equal to b, function is not differentiable. We can draw a lot of tangent here, है ना, lot of lines tangents here. ठीक है, so we cannot say, है ना. So if I'll ask you to what is the global maxima, what is the global maximum, because f of b is the global maximum. सबसे बड़ा वैल्यू कौन है भाई? f of b, है ना, f of b. सबका वैल्यू निकाल दो, f of a, find f of a, f of c, f of d and f of e, f of b, है ना. Then who is the maximum value? You can say that is global maximum. And in the locality of x is equal to c, f of c is maximum. That's why f of c is called local maxima. And at x is equal to d, in the locality of x is equal to d, f of d is minimum. That's why f of d is called local minimum. Right? I hope this is clear to all of you guys. Let's move. This is the case. And see here, this point is x is equal to a minus s, a plus s. In the locality, in the neighborhood of a is at a, you are getting the maximum value of the function, right? Okay. And also here also you can see in the locality of a or neighborhood of a, you are getting f of a is the minimum value, है ना. So this is the case of local maxima and this is the case of local minimum. I hope this is clear to all of you guys. Let's move. Now, so what is the test? How can we determine whether the function is local minimum or local maximum at those points? By using the differentiation, right? Differentiation को हम use करके हम कैसे बोल सकते हैं कि ग्लोबल मैक्सिमा होगा, सॉरी लोकल मैक्सिमा होगा कि लोकल मिनिमा होगा. ठीक है, चलो देखते हैं फिर. फर्स्ट डेरिवेटिव टेस्ट. नाउ विल डिस्कस फर्स्ट डेरिवेटिव टेस्ट, है ना. तो फर्स्ट डेरिवेटिव टेस्ट में हम कैसे करेंगे, देखो. सपोज ओके, वी आर टेकिंग ए ग्राफ. ओके, सपोज दिस इज माय ग्राफ, है ना. So suppose this is the point x is equal to a, x is equal to c, and this is the point x is equal to a, this is the point x is equal to b, right? Okay, so how can we check by using the first derivative? How can we check or how can we find the local maxima? First we'll see, है ना. So but from the figure you can observe at x is equal to c we are getting the local maximum, right? ठीक है. Okay, so before x is equal to c, the function is increasing, right? And just after x is equal to c, the function is decreasing. Yes or no? Before x is equal to c, just before x is equal to c, the function is increasing. That means f dash of x is greater than 0. ठीक है. But at x is equal to c, we are getting f dash of x is equal, f dash of c is equal to 0, है ना. But just after point c, the function is decreasing. That means the first derivative is less than 0. ठीक है, first derivative of that of the function is less than 0, है ना. That means when a local maximum occurs, so just at which point, just before that point, the function should be increasing, and just after that point, the function should be decreasing. है ना. So you can see here, है ना. Suppose f of x would have a local maxima at x is equal to a. That means f dash of a minus 0. That means we can take here. Suppose this point, f dash of c minus a, c minus 0. That means left side. When function क्या हो जाए, the first derivative of that function is greater than 0 or increasing, we can say, and just after that point it is decreasing. It means f dash of x should change its sign from positive to negative. Here increasing means positive, here decreasing means negative. ठीक है, तो positive 0 negative. स्लोप कैसे जा रहा है? positive 0 negative, right? ठीक है. अगर लोकल मैक्सिमा होगा तो फर्स्ट डेरिवेटिव ऑफ द फंक्शन फर्स्ट क्या होगा? पॉजिटिव, देन 0 at that point only, then after that point it should be negative. And for the local minimum, it must be change its sign from negative to positive. Negative to positive. Yes, you can observe here. First function is decreasing, that is f dash of first derivative of that function f dash of x is less than 0. At this point, f dash of x is equal to 0. But after this point, function is increasing. That means a first derivative is greater than 0. Okay, clear or not? The so क्या हो रहा है ना, f of x, f dash of x to change its sign from negative to positive. Negative to positive. But in case of local maxima, it is changing the sign from positive to negative. है ना? Or third one is, if f of x does not change its sign while passing through x is equal to a, then we can say f of x would have neither maximum nor minimum. If sign change नहीं हो रहा है, ठीक है? चलो, let's move. Let's see an example, guys. Let's see an example here. Okay, so this is a case, and we will check whether the function is gives you maximum or minimum, and find the maximum and minimum value also of this function, local maximum and local minimum, by using the first derivative test. So how can we solve it? How can we solve this question? So we have function as f of x is equal to x plus 1 by x. So we need to find f dash of x first. That is actually 1 minus 1 upon x square. 1 minus 1 upon x square. And we know that when f dash of x is greater than 0, that means it is increasing, and f dash of x is less than 0, that is means it is decreasing. Okay, ठीक है, चलो ठीक है फिर. So we can write this as also x square minus 1 upon x square. ठीक है, चलो. Also we will simplify this x plus 1 into x minus 1 upon x square. Okay, chalo. Now check it one by one. Find all the critical points first. What are the all critical points? Okay, how can you find? Now, if we'll take f dash of x is equal to 0, so what will happen? X square minus 1 upon x square is equal to 0. That is, x square minus 1 is equal to 0. Then we can say x is equal to plus or minus 1. So plot the number line first. This is a method to check the local maximum and local minima by using the first derivative. This is the number line. Plot the numbers. Suppose this point is minus 1, this point is 1, and this point is 0. Okay, okay. Chalo. So if you'll check by the interval, by the interval, you can check greater than, for x is greater than 1, for x is greater than 1, it becomes positive. Yes or no? It becomes positive. After 1, greater than 1 के लिए positive हो रहा है. देखो, numerator is positive, denominator is also positive. That means when x is greater than 1, function is positive. First derivative becomes positive. That means ये हो गया. And if you'll check in between 0 and 1, in between 0 and 1 के लिए क्या हो रहा है? Suppose we'll take 0.5. 0.5 के लिए negative हो रहा है ना? Numerator becomes negative, right? ये हो गया negative. And in between minus 1 to 0, it becomes also negative, right? ये भी negative हो रहा है. And less than minus 2 के लिए, sorry, less than minus 1, when x is less than minus 1, what is happening? ये मेरा positive हो रहा है. ठीक है? ये मेरा positive हो रहा है. That means we can roughly draw the figure of the first derivative of that function. That means here the function is increasing. Here the function is increasing, and again it is decreasing, and again it is increasing. Increasing means positive हो गया, मतलब ये increase हो रहा है. ठीक है? ठीक है? Okay. So now we can find what is the local maximum, what is the local minimum. At x is equal to minus 1, you are getting local maxima, and x is equal to, and at x is equal to 1. At x, sorry, graph थोड़ा और हो गया. ऐसे कर सकते हैं हम ग्राफ को। जस्ट टाइम हो गया क्या? जस्ट मिनट है ना। So at x is equal to 1, you are getting local minima. So f of minus 1 क्या हो रहा है मेरा? f of minus 1 becomes 2 and f of 1 becomes 2. f of minus 1 becomes minus 2 and f of 1 becomes 2. So this is my local maxima, and this is my local minima. ठीक है? I hope this is clear to all of you guys. है ना? By using the first derivative test also we can solve the question or we can find the local maximum or local minimum. I hope this is clear to all of you guys. First क्या करना है तुम्हें? First try to find out the first derivative of that function and then equate with 0. Then we will find some critical points and plot those points on the number line. Number line plot करने के बाद check in each interval where the first derivative of that function is positive or negative. Then draw the curve of first derivative. Then you can visualize here you are getting a local maxima, you are getting a local minima. Right? So this is the way we can find. चलो let's see next second derivative test क्या होता है? Just I am telling you what is the procedure, right? So we don't have time to solve some questions. Okay. So second derivative test के लिए क्या करना पड़ेगा तुम्हें? तो first suppose you have a function y is equal to f of x, है ना? Okay. तो first क्या करो ना तुम f dash x निकालो, ठीक है? Find f dash of x and equate with 0, है ना? Suppose you are getting x is equal to a and b, right? Then try to find f double dash x, second derivative of that function, and after finding f double dash x, what should you do? We should put in place of x, first put f double dash of a and f double dash of b. If you are getting f double dash of a is greater than 0 and it is less than 0, where you are getting f double dash of a is greater than 0, we can say here we are getting a local minima. ठीक है? And when double derivative of that function at point b is less than 0, when you are getting double derivative is less than 0, that means you are getting a local maxima. ठीक है? So this is the rule. You can see here. First, if f dash of a is equal to 0 and f double dash of a is less than 0, then we have a local maxima. Already we have told you. And second case, if f dash of a is equal to 0 and f double dash of a is greater than 0, we are getting a local minima at x is equal to a. And third case, if f dash of a is equal to 0, f double dash of a is equal to 0, then this test fails. And existence of local maxima and minima at x is equal to a is decided on the basis of the nth derivative test. And so we'll discuss the nth derivative test in later. So this is the way. And application of maxima and minima. चलो ये सही है. इसको solve. Concept of global maxima and global minima, है ना? Already I have told you, है ना? Suppose ये तुम्हारा एक curve है, ठीक है? And you need to find the global maxima, global minima, local maxima, local minima. ठीक है? तो देखो, suppose this point is A, this point is B, this point is C, and this point is D, and this point is E. है ना? So here, where we are getting a local max, we can say where we are getting a local maxima, local minima. This is local minima. This is local maxima. This is local minima. And try to find also these two values. है ना? After getting all these values, f of a, f of b, f of c, f of e, f of d. After getting all these values, check who is the maximum value gives you. है ना? Who is the maximum value giving you? है ना? Suppose here I am getting f of d is the maximum. F of d is maximum or greater than all the values f of b, f of a, f of c, f of e. Right? That means ये हो गया मेरा global maxima. ठीक है? And सबसे नीचे वाला जो वैल्यू तुम्हें मिल रहा है, suppose here f of b I am getting. So सबसे छोटा वैल्यू जो मिला तुम्हें एफ ऑफ बी, दैट इज ग्लोबल मिनिमा। ठीक है, so this is all about your global maxima and global minima, and already I told you these things. Okay, ये हो गया सबका। हाँ, these are some questions for your homework, you can take it as your homework question. Okay, so that's all for today's class. We have completed the concept, all the concepts, or we have completed application of derivative, or we can say we revised just the application of derivative, which will be helpful in your exam, right? Okay, so in next class what we'll do, we'll solve some JEE mains level questions, or some good questions we'll solve from the topic that is application of derivative. Okay, chalo, ठीक है, that's all from for today's class. Thank you all, bye bye, take care all of you, thanks for your time, thanks for your patience everyone, chalo, bye bye.